So first of all, understand what is a sequence, right? So sequence is a string that is formed or can be formed by deleting some characters, right, and no characters without changing the order, right? Means we don't want, we do not need to change any order, right, of the remaining elements, right? So that is called sequence. Let's suppose we'll have A, B and C, right? So ABC, let's suppose we'll call it a subsequence of, there is some element, right? So let's suppose we'll take element A, then there can be a string E, B, D and C, right? So if this is a string we have given, correct, if this string is given and we are only picking three elements, let's suppose we are picking A, B and C. So if you observe, we have taken what? A, B and C from which string? This string, right? So this is your subsequence, right? Subsequence of this string we have. Means we are only picking the elements, but we are deleting the element, or we are skipping the orders, right? We can delete, we can derive from the another string by deleting some or no characters, right, but without changing the orders. If you see, first A have came, so we have taken the first A, then we have, after that other elements will come, but after that B is coming, then next C will come. So what we will do, we'll take the order same as we have given in the parent string, right? And so this ABC is a sequence of this string. Understand? If we'll talk about, let's suppose we have from here, if we'll take what? A, E and C, right? A, E and C. Is it a subsequence, right? AEC, A, E and C, right? It is a not a subsequence of ABC. Let's suppose we'll take from here. Yes, this is possible. But if we'll take from here, let's suppose A, B, C, D, E. If this is the parent string, and from there if we'll take, so no. If we'll take from here, yes, it's a substring. But if we'll take from here, it is not a substring. So a subsequence, right? It is not subsequence. Substring is fine. That is different thing. So in the subsequence, right, if we'll take the subsequence from here, then this will not work, because if you see the A, B, C, D, E, right? So if you see, the first is A, then we have E, right? So E is in the last, C is here, right? The order is not there, it should be after the E, right? So if this is not happening, means this is not subsequence. Understand what is subsequence, what is not subsequence, that you should understand, right? Let's suppose, give me a second. Let's suppose we have let's suppose it's also saying repeating a sequence K time, right? If it is saying repeating subsequence K times, right? It is saying, so if it is saying repeating a subsequence K times, what does it mean? So if the sequence is AB and K equal to 3, it means if you multiply by K times, it becomes 3 times, right? AB, AB, AB. I hope you understand, right? Okay, give me 1 second. What happens now? Understand what is our goal, right? So we have to find the what? Longest substring, longest subsequence, right? We have to find the longest, you can say longest string, and that is sequence. So if we want to find the longest subsequence, right, SEQ, right? So how we have to return? We have to return a subsequence is repeated K times. That gives a new string. How we are getting the new string, right? That we have seen, right? If we multiply, it will give what? Like that, A, B, A, B, A, B. If the sec is AB and K is equal to 3, so it will return like this, correct? Means we have to find the longest string sec where sec we have given, but if it is repeating this sequence, right, subsequence k times, that will give you the new string, and that is called this. So the new string must be a subsequence of string s, right? It is also saying correct, subsequence of s. Understand? So let's understand this example. If you'll see this example, we have given what? Let's Leetcode we have given, right? And k we have given is 2. It means if we want to find the longest string, like let's suppose let, right? If this is a longest string, right? If you want to find the longest string like let, right? So we'll say let into 2. So it will become what? How it will become? Let and let. 2 times it will become, right? So this let is a subsequence of this Leetcode. Understand? Correct? So this let, right, is a subsequence of what? This Leetcode. So let is a subsequence, right? And if we'll also do what? Let's suppose we'll say e t e, right? If we'll take this one, right, let's suppose is also, but let is longer, right, and lex larger. We can say that there can be possibility either you can take this or this, right? If you will taking this or this, right? So if you observe that we have taken e t double ete, like that, means first of all we have taken this part, and due to the multiply we have multiplied by this one, right? So either you are taking let's or let, right? Either you are taking this part, the green one, the first green you are taking, or you are taking the after that, right? What we have like that. So after you are taking this or this, right, there is two possibilities, right? Either this or this, right? So which one is taking, right? But we have to take what? The longer one, and that is why we will choose this green one, right? Because there is two subsequence, right? Either you repeating let or ete, right? So either you're taking this part let or double e t or ete, you can say, right? So which one is larger? That having the larger lex, right? Lex is larger, and so that we will consider for this example. Understand? Now understand, we have given another example right here, right? So if you consider example 2, what we have given? Yes, we have given what? B and B. Two things we have given, and k we have given 2, right? So let's try the sequence. We'll call it a sequence, right? Is a b, we'll take from here, right? So if we'll take the sequence from s to b, right? So if we will say b and we'll multiply by 2 because k is 2, so what will come? It is come b b, 2 times coming. So the b b is a sequence of this string, right? Yes, it is. So we'll say yes. But if the sequence itself will take b b and this, and will multiply, because every string itself can be a subsequence, right? And if we'll consider the sequence and will multiply by 2, right, what will it come? Double b, it will come. So is this a valid subsequence? It is too long. It is too long. And so because it is only 2, size was only 2, it is having 4, and is better, it's not better, it's too long, right? And so we'll consider no, this is not. So better consider only this sequence. Understand? What you have to choose, that you have to understand. Understanding or not? Now understand example 3. Okay, Example 3 we have given what? S equal to AB, correct, and K equal to 2. Okay, so if we'll take the sequence from here, let's suppose we'll call A, right? A is a subsequence of S, we can say that. And if we will multiply by 2, what will it come? It will come A 2 times. So if you say AA is not in AB, it is not in AB, right? So we'll not consider this. Let's try another sequence, right? It will call B, right? If you multiply by 2, it will come what? BB, right? It is not also in the B, in the string, right? It is not there. So both of these is not present. It means there is no valid sequence. There is no valid sequence repeated 2 times. It is called empty string is returned. I hope you understand, right? Means what we need to do, we have to find the longest string, right? Or you can the sequence, right, after generating from here. So we have to find the longest string sec, right, such that if we write or you can multiply with k times, so the resulting string is, let's suppose, hidden inside S. If it is inside or hidden inside this, right, means it's a sequence of subsequence of string S. That we have to do, means we have to find the sequence, this sequence, resulting sequence, we can say, right? We have to find it. I hope you understand the problem, guys. If you not, please ping me in the comment box. So if we will talk about the intuition for this problem, right, means we want to find what? Longest subsequence, that is called sec. In such a way, if we will multiply by k, right, so still a subsequence of string S, correct? And among the multiple such subsequences of the same length, we have to return the lexicographically larger one. And so, but we can also say we have to try, in this case we have to try what? All the subsequences, right? We have to try all the subsequences, and it should be right. And if we'll try all the subsequences, means we can say it's too slow. Why? Because exponentially we have to find everything, right? All the subsequence we have to generate. But if we'll try to find all the subsequence, means it's too slow because of the exponential thing, right? So what we can do, we should use let's suppose a breadth first search, BFS, right? Why will use the BFS? So BFS is good to generate the string by adding characters, right? If we'll add the character, right, if we want to generate the string, right, so the BFS is best approach to generate, right? And then we will so the candidate character, like those character that appears at least k times, right, those we have to find it, right? And each time when we build the new candidate, you can say, so we just multiply with the, let's suppose candidate was, let's suppose A was coming from AB, right? It was coming right from the A. So this is a subsequence itself. So if each character, let's suppose we'll call is a candidate, to it will multiply k times, right? K times will multiply. So each time we will build a new character, a new candidate, we can say. Let's suppose it is k equal to 2, we are saying AA, right? So this is our new candidate. So this candidate is valid or valid of subsequence of S or not, right? If it is valid one, right, it means we are good to go, right? Means first of all we'll find the BFS, then we will limit the candidate characters to only those that appears k times, right? At least k times, right? And each time we will build a new candidate, right? And after multiplying the k, and we'll check is it is a valid subsequence or not. If it is valid one, then we will continue, right? We'll check the further lexicographically bigger one or not, right? It means if we'll talk about the high level approach, right, what we should do, right, we should do what? First of all, we'll count the character in frequency. We should count the frequency, but count the character frequency, right, in S, right? Then what we should do in the next step, we'll pick the character that appears at least k times. What we will do, we'll pick the characters whose frequency, right, whose frequency is at least what, at least k times, correct? If the character frequency is at least k times, right, means we are good to go. Then we'll use what, BFS. BFS will take the Q, right, and we'll use the BFS and build the candidate sequence, correct? And we'll start with the double quote, right, and we'll each time we'll level up adding a valid character, correct? That we will do here. That will show you how to do that. Okay, then we'll check if the candidate is multiplied by k, right? If it is, the sequence is a subsequence of S. If it is valid, then we'll track the longest one, then track longest candidate, right? Means lexicographic graph, it should be lexicographically it should be larger, right? And then we'll finally will return what, the result, and return the result, correct? Okay, so let's understand how to implement it. So what we have given a string, we have given k, we have given, and we have to find the longest one, right? Longest subsequence that is repeated k times, we have to return it. Okay, so let's suppose we'll call this string is what we have given, is equal to, let's lead code was given in the example one, right? So we'll call this string, and k is given nothing but 2 we have given, right? So if these two things we have given, right, so first of all what we need to do, as I told you, first of all we'll count the frequency of each character and we'll store on the frequency, right? So just take the frequency of 26 characters, right, because the English letter character is 26. So we'll take the array and we'll add the frequency over here, right? Now you know, if we'll store the frequency, so it will look like how, let's suppose this will the English letter, so it will start from where, let's suppose 0, and we'll go till what, 25, right? And so for each character we'll store here, let's suppose the L will come somewhere, right? Leave it for now, right? So there will be A is there, A is not in there, so we'll call it a 0. So similarly we'll keep moving here, right? And let's suppose here is L, right? So L having 2 as a we call frequency, because L is coming here and here, right? Let's suppose E was also coming, so let's suppose E is here, so E is coming 4, so we'll say A is equal to 4. Means if we'll write the frequency rather than writing this, what I can do, okay, so what we can do, just say that the frequency will look like this. How? Let's suppose L will come 2 times we have, then we have E equal to 4, then we have T equal to 2, string S, let's S we have 1, then code we have C1, then D we have 1, and then O, Leetcode O we have 1, right? Like that, these are the frequency we will build right here, and it will look like this. Now what we should do, we'll prepare the valid characters whose frequency is greater than or equal to k, and we'll do reverse lex order. Why? Because let's suppose we have the valid characters, right? So each character will store on this list, right? So if the frequency at I is greater than or equal to k, it means this is the valid character, right? So we'll add it here. On the valid character we'll add here, right? And whenever we require it, right, we'll use it, right? So what we will do, we'll prepare the list of all the valid characters, right? And so we'll use a list of characters here whose frequency is greater than or equal to k. So if the frequency greater than or equal to a, will use these valid characters at one place. So let's suppose in this case where k is equal to 2, right? Right here k is equal to 2, right? So if you observe that there is only few characters are valid. Let's suppose from here if we'll choose what other frequency are valid, right? So if we'll call it, we can say that the frequency L having frequency is 2. What happened? If the frequency is L we have taken from here, then we can say E, we can take E, then we can T, this is also valid, we can take T, S we cannot take, D we cannot take, C we cannot take, O we cannot. So only these are the few characters which are valid, so we'll take into the what? In this valid characters, right? So we'll store all these character there, right? And so we'll take that in, if we'll take the reverse order, so it will look like how? We'll take T first, then it will come L, and then it will come E. So this will be in the what? In the reverse lex order. This is in the reverse lex order, right? So we'll take it like this. Then what we have to initialize the BFS, right? We'll start with the BFS here, and this BFS is will take Q string and will offer with the empty string, right? So we'll start with the empty string, right? And we'll keep adding all these characters that we have taken, T, L, E, right? So we'll append first T, then L, then E, right? So we'll append, if we will append this, let's suppose for the first time, if we'll append this, right, what will it become? So we'll first append T, it will look like this T, then we'll append, next time it will come L, we'll append this L, then we'll append what? E, so it will append like E, correct? So each character will append like this, and we'll check what will multiply with the 2. So T into 2, it will become what? TT, correct? Is this a subsequence? Yes, it is sequence. Then we will add into the result. Similarly, we'll multiply others, right? So if we'll multiply these things, it will become what? Double T we can say. So this is valid. Then if we'll multiply E and T, so E and T will become what? LT we can also say. First we'll multiply L and T. So L and T possibility is there, L and T, then ET, right? So all are the valids. So we'll keep adding on to the Q. So Q, we will add this and we'll continue building the letters. So if you observe that, right, we have got what? LT, then we have got LE, right, and then we have ET. So these are the valid one. So we'll take one, what? LET, let. If we'll take LET, right, which is a valid longer one, right, and so we'll say this is a valid longer one. And so if it is valid longer one, so we'll say L and T is valid one between ET, LT, ET, whatever these combinations are there, right? In between LET is the longer one, and so we'll finally add into the result. Okay, so let's go to the rest of the code. What happened? Okay, so keep going. So we'll keep adding onto the list, and once this is ready, we'll keep adding onto the what we call on the result, right? And we'll also check this method. We'll having a helper method. We'll check each character. So count is get equal to k, right? Will return is true, right? So we're checking this. It is greater. If it is greater, right? Or we can check the next sequences. We'll keep checking the length. If length is greater, we'll keep adding on to the queue, and finally we'll return the result, because we know if we find the longer lexicographically, we'll have our result, and so we will return the result here. Okay, so I hope you understand. If you have still doubt, please ping me in the comment box. So let's summarize this, right? So very first, what we will do, we first we need to find the character that occurs through k times, right? And that is why we cause to repeat a sequence k times. Each character in the sequence must appear at least k times. So we'll take the frequency, and we'll go for the frequency for each character, counting the frequency of each character, right? Then we'll build the you can say list of character with which frequency is greater than equal to k. It means this piece of code. So if we'll build the list of character, so this will reduce the number of character we will use to generate the candidate. We will also do it in the reverse lexicographically order to ensure we are trying a larger lexicographic subsequence in the first. Then we'll go for the BFS, right? So BFS to explore all the valid subsequences will go, where we will define this piece. Will start with the empty string and will try repeating every valid character. If the new string say AB multiply k times, that is become ABAB, right? It's a sequence of S, and will keep it and will use BFS to generate longer and longer subsequences. Okay, then in the next step we will build the candidate, right? And we have we will try to append each character, right? So means we want to check the subsequence checker. This is step is you can say subsequence checker. Will find the subsequence checker, and for that we'll create a subsequence checker method, helper method, and it will check the subsequence method, right? And once we have checked the subsequence method, if it is great, if length is greater than, you will store on the result. And this is your subsequence checker method, where you will check the subsequence. If each character you will check, and it should be equal to this, right? And it should be equal to k, will return true. Okay, so if we'll talk about the complexity, right? We have O of n characters we have given in the n is the number of characters we have given, let's suppose, in the string. So we are generating you can say using this BFS, we are generating all the possible sequences, right? But we also generate the string using only characters that appears greater than k times, correct? So if it is greater than k times, so we can say let's aim be the valid characters, which is 26, right? And let's suppose L is the maximum valid subsequences, right? That is depends on the length of the character, right? And the frequency, right? That is practically less than equal to 7, we can say that, right? So the total complexity will become 26 to the power complexity like become 26 to the power we can say 7, correct? So the maximum possibility that let's suppose total candidate will be possible, but m to the power l means the binary tree of height l and balancing factor is m, correct? So not here, at 7. Okay, okay, means why we are taking 26 to the power 7? Because in the worst case 26 to the power 7 is 8 million, but in practical much smaller due to the frequency constraint, right? So the total possible candidates become what? M to the power l, right? And so l is the height of the tree and m is the branch factor, right? And so we'll check all the you can say repeated subsequences each time due to this helper method, right? So each time if we'll check the sequence, right, is called it will take O of n times, right, to check all the characters. And so let's suppose we'll check number of character is O of n, right? So it will become O of n, right? And if we are checking c characters, let's suppose we'll say O into O of c into n, right? It's still O of n characters, right? So total time complexity we'll talk about in this case will become what? First we have taken let's suppose O of what? Not O, we can say O of the first was what? M, the number of valid characters, right? So if valid character is there, right, and the height of the tree or even the maximum subsequence length we can say is 7, right? That is practically it is less than equal to 7, right? And n is the length of string, right, which is around less than 2000 was given in the constraint, right? So we'll multiply by 2000, right, like this. So not multiplying 2000, we can just directly take n, right? So m to the power 7 we can say, m to the power 7 we can say, into will multiply this, right? So I hope you understand, guys. If you have any doubt, please bring me in the comment box. Thank you for watching this video.